Hi everyone. Today I wanted to work an impulse problem out for you because we don't have any screencasts of that yet. So this is an impulse problem concerning a tennis ball that's moving towards a racket or something. So here you have I've asked for the final velocity of a 90-gram tennis ball moving initially at a speed of 60 meters per second. And it's impacted with a force of 220 newtons in the opposite direction for a force of 0.05 seconds. Now, how do we know it's an impulse and momentum problem? If you make a list of what you know force, and you know time, and you know initial speed, and you want the final velocity. So given those, it's really the impulse equation that works the best. Now, the next thing to do is to draw a diagram, which I've done for you, where you have the ball here. I've drawn it moving to the right, and I've drawn a velocity vector here, 60 meters per second. And then you've got a force that's going in the opposite direction. I'll just draw the force up here. The force is 220 newtons. Now, it's important that you decide which direction is going to be positive, but it doesn't particularly matter which way is positive. I've said that positive is to the left. I've said that because that way it tends to make the final velocity make more sense if you have positive being the direction of the force, but it really doesn't matter. Your signs will line up at the end. So if we use the formula Ft equals mv minus mu, we've taken the vectors into account. The next thing to consider is this mass. This mass of the tennis ball is 90 grams. A lot of times people have been using whatever number is given as m in the equation, but that m needs to be kilograms. So 90 grams we divide by 1,000 is 0.09 kilograms. So our formula, when we put in the numbers, becomes this: 220 newtons times 0.05 seconds equals 0.09 times v, which is what we're trying to find, minus 0.09 times a negative 60. Remember, the initial speed is in the negative direction. Now 220 times 0.05 is 11. That equals 0.09 v. And 0.09 times 60 is 5.4, so that's plus 5.4. And so if we move the 5.4 to the other side, that gives us 5.6 equals 0.09 v. And we want to divide both sides by 0.09. So we take 5.6 divided by 0.09, and we get a final speed of 62 meters per second, positive. 62.2 meters per second, and that's to the left or in the direction of the force.